In Module 3, we'll begin with the first of 5 lifestyle factors that significantly influence your health and how effectively your brain heals and grows throughout life. The neuroscience of exercise will provide guidance into what type, duration, and frequency of exercise is optimal for neurogenesis. You will learn how to use exercise to counteract the toxic effects of stress. So have you exercised this morning for 30 or more minutes? If you have exercised, your brain has been flooded with neurotransmitters and growth factors, improving your ability to focus and retain this information. In September 2016, it was written in Time magazine, if there were a drug that could do for human health everything that exercise can, it would likely be the most valuable pharmaceutical ever developed. Learning is our evolutionary survival mechanism to adapt to our ever-changing world. Exercise improves our ability to learn at a cellular level. Exercise primes our brain to focus attention, absorb new information, and retain knowledge. Learning creates new neural pathways between cells, with new memories physically integrated into our brain structure. Our brain is an adaptable organ, ready to learn and ready to grow. We can optimize our brain functions by understanding how these systems work and how to empower them. Exercise is good for you, but why? We're told exercise is important. At times we receive context. Exercise improves heart health. Let's learn exactly what happens neurobiologically when you move your body. Most importantly, how can you use this knowledge to your benefit? Let's take a look at the benefits of exercise. Our brains function like muscles. They grow with use and wither with inactivity. Responsive exercise describes when we exercise in response to stress, as we referred to when discussing the cortisol cleanse earlier. Responsive exercise reduces stress, protects from depression, and improves health. Proactive exercise promotes health and well-being, improves focus and attention, optimizes learning, memory, and mood. Exercise increases our rate of neurogenesis, produces neurotransmitters and growth factors that have powerful influences over mood and emotions. Exercise is as effective as medication and psychotherapy in treating depression. This knowledge can empower motivation to exercise. To apply the knowledge we will be discussing on the neuroscience of exercise, we need to first understand how communication occurs in the brain. Let's take a look at the parts of a neuron and how they are involved in communication. Here we have a close-up diagram of a neuron. You can see the many shorter root-like branches called dendrites extending out from the middle of the neuron. These dendrites receive information from other neurons. Each neuron in our brain has one branch extending further away than the dendrites. This is called the axon. The axon is thinner than a single human hair. Neurons communicate with one another throughout the brain by transporting messages along axons via electrical impulses. The purple cylinders coating the axon are called myelin. This fatty coating helps to improve signaling and in turn communication speed. The end of an axon divides into multiple branches, each having a synapse which can connect with other neurons. Remember, we have approximately 86 billion neurons in our brain. Each neuron can have thousands of connections with other neurons, creating a complex, interconnected neural system. We have learned that communication between neurons involves electrical signals traveling through outgoing branches of a neuron until it reaches a gap between synapses. Neurotransmitters transport messages across the gap in chemical form, as demonstrated by the purple spheres in the image. On the receiving synapse, neurotransmitters connect into receptors, and ion channels open, turning the signal back into electricity. If the electrical charge in the receiving neuron reaches a sufficient threshold, a subsequent signal is fired along the axon of the receiving neuron. This process continues throughout the brain, signaling relevant neurons to achieve the desired outcome. 80% of communication in the brain involves two key neurotransmitters. Firstly, glutamate. It's an excitatory neurotransmitter. It builds electrical activity to begin neural communication. Glutamate strengthens neural connections. The more a connection is activated, the stronger the connection becomes. Hence the saying, neurons that fire together, wire together. Glutamate is a vital component in learning, and we know that exercise increases the production of glutamate. Next we have GABA, gamma-aminobutyric acid. GABA is an inhibitory neurotransmitter, and it puts the brakes on neural activity, an important balance to help the flow of communication in the brain. Exercise also increases the production of GABA. Three key neurotransmitters involved in regulating communication in the brain include serotonin, which regulates mood, social behavior, impulsivity, aggression, appetite, digestion, sleep, memory, and sexual function. Serotonin is like the police of the brain. It keeps brain activity under control. It modifies unstable brain activity that can lead to depression, anxiety, and obsessive compulsiveness. Low levels of serotonin are linked to depression. A medication that can be used in treating depression is selective serotonin reuptake inhibitors, otherwise known as SSRIs. Their job is to prevent serotonin reabsorption to keep levels high, in turn elevating mood. Next we have norepinephrine, which amplifies signals associated with attention, perception, motivation, and arousal. And dopamine. It's our biological reward system. Dopamine is linked to learning, attention, satisfaction, and movement. Dopamine motivates you to do things. Low motivation and fulfillment can be experienced if our dopamine systems are not working efficiently. Chronic substance use floods dopamine receptors, impacting on their efficiency. Exercise boosts motivation by increasing dopamine storage and triggering creation of more dopamine receptors. Dopamine provides us with the willpower and the focus to complete tasks. Only 1% of neurons produce serotonin, norepinephrine, and dopamine. Those neurons can instruct a neuron to make more glutamate, make a neuron more efficient, alter the sensitivity of a neuron's receptors, override or amplify signaling, and adjust the flow of information to fine-tune the balance of communication through the brain. Most medications used to improve mental health target one or more of these neurotransmitters. For example, Ritalin eases ADHD by raising dopamine calming the mind. Exercise increases these three neurotransmitters and balances their activity, keeping your brain in balance, improving mental health and quality of life. We will now learn about an important protein called brain-derived neurotrophic factor, or BDNF for short. Now, we've talked about neurotransmitters, and we'll remember they are responsible for signaling and communication in the brain. When looking at growth factors, these proteins are responsible for building and maintaining brain infrastructure. In 1990, BDNF was discovered in the brain and found to have nourishing effects on neurons. Before 1990, there was limited research into this field. However, since this time, when we identified that BDNF is in the hippocampus and its influence on memory and learning, there have been thousands of studies. BDNF has been compared to fertilizer for the brain, optimizing brain cell development and growth, while also improving the survival rate of new brain cells. As we talked about earlier, through the stages of growth in a newborn neuron, some of those new neurons will not survive. Having a brain flooded with BDNF will increase the survival rates of newborn neurons. What does BDNF do? It improves neuron function, growth, and protects against cell death. BDNF is required for neurogenesis and increases the number of newborn neurons created. It improves mood regulation, cognition, memory, and learning. And even in a science laboratory, when BDNF is applied to neurons in a petri dish, neurons begin to sprout new branches. BDNF is required to optimize learning through amplifying neuron growth. BDNF triggers a cascade of dopamine and gradually produces more dopamine over time as well. Productivity is improved by BDNF, enhancing focus, attention, performance, and a sense of accomplishment. Low BDNF levels have been associated with depression, bipolar disorder, schizophrenia, and neurodegenerative diseases. Stress and its associated excess cortisol levels also reduce BDNF levels. We have learnt that exercise increases important neurotransmitters and balances their activity. Exercise also increases BDNF levels. Let's take a look at 3 types of exercise and how they each influence health and well-being from a neurogenesis perspective. Firstly, we're going to look at resistance and strength training, otherwise known as weights. Then move into high-intensity interval training, known as HIIT. And finally, look at aerobic cardiovascular exercise, also known as cardio. Resistance and strength training involves increasing muscle strength by making muscles work against a weight or force. Types of resistance and strength training include free weights, weight machines, resistance bands, and body weight movements. Resistance and strength training can involve a number of exercises focusing on the same or a combination of body groups, completing a number of sets, with each set including a number of repetitions. Research has shown resistance and strength training has a limited influence over our rate of neurogenesis, however, does elevate BDNF levels. High-intensity interval training involves short, intense, unsustainable bursts of physical activity, followed by short intervals of rest. This sequence of intense activity, followed by short rest periods, causes metabolic disturbance, which supports the body to burn calories for up to 24 hours post-exercise. HIIT's intense phase involves maintaining 80 to 95% maximum heart rate, and recovery periods aim for 40 to 50% maximum heart rate. High-intensity interval trainings exercise has a slightly better influence on neurogenesis compared to strength and resistance training, and it also elevates BDNF levels. Aerobic cardiovascular exercise involves engaging in constant movement that increases your heart rate and rate of breathing. Some examples of cardio include a brisk walk, running, swimming, cycling, skipping, or aerobic classes. Research identifies cardio as the optimal exercise for increasing our rate of neurogenesis, with increasing benefits the longer the duration of exercise is. Increases in BDNF have been found to be an average of 32% after 20 to 40 minutes of cardio, with the maximum benefit being from vigorous cardio, where your heart rate achieves 80% of its maximum for 40 minutes. Comparing active participants to inactive control groups whose BDNF levels drop by 13% while being inactive, the difference in BDNF is 45%. So next time you're contemplating going for a walk, just remember that you could be accessing up to 45% more BDNF, empowering your system. Extensive research has found vigorous cardio elevates BDNF levels specifically in the hippocampus. We have learnt that exercise floods our brains with brain-derived neurotrophic factor, increasing the number of new neurons created through neurogenesis, with cardio exercise achieving the best results. So exercise optimizes neural growth in the hippocampus, increasing this vital structure's physical size and improving all of its functions. We experience enhanced memory, improved mood, improved cognitive functioning, including clarity of thought, and improved learning capabilities. Higher levels of BDNF counteract chronic stress and cognitive decline. Exercise also improves cognitive flexibility, problem solving, and creative thinking. Exercise provides an antidepressant effect and is a key part of lifestyle factors that provide our best attempt at preventing Alzheimer's disease. Exercise also helps in treating addiction, as it promotes the development of detours around pathways in the brain associated with addiction, allowing for reduced intensity of cravings, urges, and impulses while developing healthier habits in line with your desired goals. We are now going to learn about a molecule named atrial natriuretic peptide, or ANP. ANP is a molecule released by the heart during exercise. It provides a calming influence to the brain, nervous system, and body, essentially putting the brakes on our stress response system. ANP increases in our system as our heart rate increases during exercise. So regular exercise helps to empower our system to remain in balance, being able to switch off our stress response in a modern world where it is triggered frequently. Pregnant women can produce up to 3 times more ANP, and this may be nature's biological protection against stress for mum and bub developing in the womb. Let's take a look at an example of how a school district was able to integrate this knowledge of the powerful benefits of exercise into their educational program to optimize outcomes for their students. In the 1990s, the school district of Naperville west of Chicago, USA, introduced a revolutionary new learning readiness physical education program. Almost 20,000 students participated in the program with a focus on optimizing the benefits of movement to enhance cognitive performance and academic achievement. Students learnt the principles, practice, and importance of fitness from the 5th grade. There were 18 choices of fitness activities, including rock wall climbing, basketball, running, and dance. Students learnt to track their performance using heart rate monitors, measuring blood pressure, and cholesterol levels. The goal was to maintain a heart rate of 160 to 190 beats per minute for 25 minutes in their chosen activity, with a focus on fun ways to engage people in physical activity. This was a shift away from traditional physical education programs, where students were often stationary, waiting for their turn, only experiencing short bursts of movement. After one semester of the new Learning Readiness Physical Education program, students demonstrated 1.34 years progress in literacy and over 20% improvement in algebra compared to peers not involved in this program. In 1999, Naperville's results on an international standards test of mathematics and science were astounding. 97% of Naperville's 8th graders took the test, not just their brightest students. And they achieved first in the world in science and 6th in the world in maths, with only 7% of USA students achieving results at this standard. The toughest academic classes were scheduled right after learning readiness physical education to access the optimal window of BDNF and boost in dopamine post-exercise. After exercise, students were more prepared to learn. Their senses were heightened, they were focused, with mood improved, they were less fidgety or tense, they were more motivated and invigorated. Only 3% of students were overweight in Naperville, compared to the national average of 30%. When we exercise intensively, our body perceives this as a form of stress. Our stress response system is activated and we produce cortisol. As our fitness improves, our body improves at managing physical stress. And less cortisol is then released during stressful experiences. So through exercise-induced stress, our brains experience a safe activation of our stress response system, one we are choosing to be involved in and enjoying. And this safe exposure to stress helps our brain become adept at responding to future stress. If you're wondering how much cortisol is released when we exercise, we know that physical effort exceeding 60% maximum oxygen uptake induces cortisol release by almost 40% above resting levels. Exercise-induced stress response tricks the brain into reprogramming the cognitive state of stress to one that says stress doesn't always have to be a threatening state or experience. So even though exercise produces cortisol, levels drop afterwards and continue to decrease gradually over time. So morning exercise can prepare us for our day, and afternoon exercise can help us to cleanse cortisol produced throughout the day from our system. A key learning is exercise promotes stress resilience. There are many ways to move your body to achieve the health and well-being benefits that come from exercise. The key is to find a movement you enjoy. Aim for 30 minutes of increasing your heart rate so that you're sweating. You could go for a walk, enjoy a run, participate in a gym class, Go for a hike or ride a bike. Play a sport. Play with your children. Dance, because your brain is growing with every song. So what is your movement? What do you love to do? What has exercise looked like at different times in your life? And what do you want it to look like in your future? Exercise is a necessary part of life. Find an activity you enjoy, mix it up, do it with others, and gain the benefits of flooding your brain with feel-good, healthy neurotransmitters. You are counteracting stress, preparing your body to perform at its potential, and giving yourself a natural, healthy experience of happiness.